Welcome learners. This is final module 6 of Unit 2 Mineralogy. In this module we will be seeing about clay minerals and gypsum. Myself Sarath Kumar, Assistant Professor, Department of Civil Engineering. In this module we will be saying in clay minerals and gypsum mineral we will see about its chemical composition, atomic structure, varieties, physical properties, occurrences and uses. First we will see about clay minerals. Clay minerals are mainly formed due to alteration or decomposition of pre-existing silicate minerals. To some extent they are formed due to hydrothermal activity also. This pyroxene group of minerals upon decomposition, upon weathering, results in clay minerals. They are extremely fine grained and are less than 0.01 mm. Most of them are soft and exhibit plasticity when mixed with limited quantity of water. As a civil engineer, we will study clay minerals in geotechnical engineering. Clay minerals have a special property called plasticity. That is, you can mold clay minerals into any shape upon adding some fixed quantity of water. We will be studying all about this plasticity and what are the various properties of clay minerals in geotechnical engineering also. Chemical composition and atomic structure of clay minerals. All clay minerals are basically hydrous aluminum silicates. Some have little potassium, magnesium, sodium, iron, etc. Atomic structure. They are phyllosilicates. That is, in their atomic structure, SiO4 tetrahedra are arranged in sheet pattern, that is, growth in 2 dimensions. It resembles in sheet, crystallize in the monoclinic system. The various varieties of clay minerals are kaolinite, halloysite, montmorillonite, bedillite, pyropylite, allophone, illite and chlorite. Upon all these varieties, the most common occurring variety are kaolinite, illite and montmorillonite. We civil engineers have to know about these 3 common occurring clay minerals: kaolinite, montmorillonite, illite. Physical properties. Since clay minerals, by virtue of their extremely fine grain size, are indistinguishable from each other on the basis of physical properties. You cannot see the physical properties through your naked eye. They can be identified on the basis of their structure from the studies of X-rays, optical electron microscope and DTM. DTM means differential thermal analysis methods. So you cannot differentiate various clay minerals using physical properties. It should be studied either in X-rays, using X-rays, optical electron microscope and differential thermal analysis methods. Special properties. In montmorillonite, the aluminum is substituted by magnesium. To balance the resulting negative charge, Na plus and calcium plus plus means sodium and calcium ions get attached to the surface. These positive ions are exchangeable bases and their presence accounts for the special property of the high base exchange capacity of the mineral. So in montmorillonite, the base exchange capacity of the mineral is very high. In this mineral, the molecule water can be removed by heating. Such minerals swells largely on absorbing water again. So in montmorillonite mineral, you can remove the molecular water, not the absorbed water, not the adsorbed water. You can remove the molecular water by heating. When you again add the water, it swells to a large extent. Vermiculite. A mica-like mineral of the chlorite group, when heated suddenly, extends up to 20 times of its original volume. It extends up to 20 times of its original volume. Occurrences. Clays, which are the products of weathering, may remain in the same place they have been formed or can be transported by natural agencies and deposits as beds in sea or lakes as blanket clays, boulder clay and loess. This we have seen. When a primary mineral is weathered, it results in clay. If it is deposited at the original parent site, it is called residual clay. If it is transported and deposited in some other place, it is called a transported clays. Loess is the transportation by wind. Fire clay is often found beneath the coal seams. Uses of clay minerals. Ball clay means kaolin with large silica content, which has a high plasticity, is used in different ceramics. Since they have high plasticity, upon adding water, you can mold this type of clay into any shape, which is used in different ceramic industries. Fire clay. It is also one form of kaolin clay with impurities of oxides of calcium and iron, etc. Has both plasticity and refractoriness. Refractoriness is resistance to heat. Is used in the manufacture of acid refractory bricks. So when you want to construct a brick, when you want to construct chimneys with bricks, these type of fire clay are used to manufacture those bricks, since they are very resistant to heat. Refractoriness is resistance to heat. Bentonite clay, volcanic ash, is used in drilling muds as decolorizer of oils and fats, and as foundry sand in toothpaste, cosmetic preparations, and as a binding agent in pelletizing iron ore fines. China clay, which is nothing but kaolin, is used in the manufacture of crockery and in industries producing textiles, paper, rubber, paints, cosmetics, etc. So these are the uses of clay minerals. The final topic of this unit is gypsum. Gypsum is a sulfate mineral. Since calcite we have seen, previously we have seen calcite, which is a carbonate material, and before that we have seen feldspar, pyroxene, amphibole microgroup, which is silicate group. Gypsum is a sulfate group. Gypsum is a sulfate mineral, usually occurs as a sedimentary deposit. Gypsite is a mixture of gypsum, sand and dirt. A picture of gypsum is shown in the slide. The chemical composition of gypsum is calcium sulfate 2H2O. Atomic structure, crystallized in the monoclinic system. The common varieties of gypsum are satin spur, selenite and alabaster. Physical properties of gypsum. Form: lately fibrous, foliated. Color: colorless. Streak: white. Luster: pearly. Fracture: even to uneven. Cleavage: one set, perfect. Hardness: it has very low hardness. It can be cut with knife also. 2. Density: low, 2.3. Degree of transparency: transparent to translucent. Special property: it is sectile. As I told, it can be cut with knife. Since it has a low hardness, it can be easily cut using knife. Occurrences: it occurs in lagoons where ocean water high in calcium and sulfate content can slowly evaporate and be regularly replenished with new resources. As a result, the accumulation of large beds of sedimentary deposits of gypsum is formed. So when the ocean water containing high calcium and sulfate evaporates, it leaves sediments of calcium and sulfate, which reacts together, forms gypsum. As this process goes on, large beds of sedimentary deposits of gypsum is formed, and it is commonly associated with rock salt and sulfur deposits. Uses of gypsum. Gypsum is used in the manufacture of cement to retard the setting time of concrete, initial setting time of concrete. It is also used in wallboard as plaster of Paris and soil conditioning. Varieties of gypsums like satin spur and alabaster are used as ornamental stones, but due to its low hardness, their durability goes down. Thank you.